All right, so I think we're good. Yeah, the TV's off, my love. So we're going to review yesterday's homework, but before we do that, we're going to look at testing groups. So here's the current groups. For those of you that said a specific time slot, I put you in there. If anyone here wants to change that, speak now. Note that you're muted though, so you'll have to unmute yourself. Okay, I guess everybody's good. So the homework starts with this one. It's just talking about correlation. Both of your calculators, the TIs and the Casios, can easily do these. So just basically button mashing for this. It says the effects of temperature on marathon runners' performance by who cares. We're given in New York City Marathon times in recent years. Results are listed below. Is there a correlation between temperature and winning time? Does it appear that the winning times are affected by temperature? So we got our X list and our Y list. I'll start with the TI. Again, if you're a TI user, make sure you have diagnostics on. If you haven't watched the video yet, go do that, because you're going to need to type in these things in a list. If you don't have diagnostics on, it won't tell you anything. So first, go to your top of your list and clear them. List 1 and 2. Put X's in list 1, Y's in list 2, and you're always going to be good to go. Let's move this over here. 73, 51, 57. All right, I have 8 numbers. Let me make sure that's the right number of numbers. 1, 2, 3, 4, 5, 6, 7, 8. Good. Didn't skip any. Now we come over here and type in the Y's into list 2. For Casio users, it's called list X and list Y. Simple enough. Move this over. Now, I have both my lists. They should have the same number of numbers. They both better have 8. If they don't, you missed something, go back and fix it. Quit out of there, second mode to quit. And then all you're going to do is run the linear regression. Stat, calc, number 4. And if you do, let me clear that. On your screen, you'll probably see something like this. Just linreg ax plus b. That's perfectly fine. You don't need to type in the list as long as you use list 1, list 2. If you use list 1 for x, list 2 for y, it assumes that. So hit enter, and it'll give you a, b, r squared, and what we need is r on this one. So r right here is 0.183. So r is 0.183. I'm pretty sure that's not correlated. Remember, the closer it is, the absolute value of r is to 1, the stronger the correlation. This is pretty close to 0, so it's probably not correlated. To check though, n is 8. So let's go to our table. Go to your formula sheet. Let's see, there you are. And on page 3, that's the second page is front. You'll see table A6 right here. That's what we're looking at. N was 8. So we're looking right here. N was 8. So if R was 0.707, it would be correlated at a 0.05 significance. R, and it, for alpha is 0.01, it would have to be even higher at 0.834. Our correlation coefficient R was 0.183. That's meaning ain't no correlation. no correlation. And that's as fancy as we're going to get with the hypothesis testing here. I'll redo this with the Casio. You're going to go to mode. So let me wait for a second, make sure you all have your calculators with you. We're going to do mode number 3. Oh my goodness, you got all your cars out? Mode number 3. And then we're going to do number 2 here. Oh, you're okay. We're going to do a number 2, a plus bx. And we type our x's in the x list, our y's in the y list. So just type them in there. X, y, it's going by rows. And we got 8 numbers, that's what it should be. I'm gonna go to the right and just go down to get all the way back to the top. Make sure you're starting on row 1 whenever you're in the y's. Don't accidentally start on row 2, otherwise you have to restart everything. So row 1, start typing in these y values. Oops, yeah, I did, okay. And even though it only displays 2 digits, you can still, it still saves the 3 decimal places. 148.1, 47.617. So it says 61, but if we hover over it, it's 617. 146.4, 144.667, 147.533. All right, once you have that, hit AC. Notice we're in stat mode, so we're good. Shift 1. Now you look here at different things. We're talking about regressions. That's what we're going to be dealing with. Reg number 5. Notice it says A, B, and R. So that's the 3 things we're going to need for this entire section here, this entire chapter really. Number 3, it equals 0.183127. Same exact thing we got on the TI. So again, that's our R value. That's our correlation coefficient. So we say no, there is no correlation between winning times and temperature. That's it. Any questions on that one? Okay, next. So I will do, let's see, do I have one? I will do one of these by hand, just so you can see the process. In fact, let's do this one by hand. We're going to be using these formulas from chapter 10. They're not fun formulas. We need this correlation coefficient. That's what we need. Now, typically, as I said in the video, we're going to be given that sum of x, y, sum of x, sum of y, etc. However, these problems just gave you the data, so we're going to take that data and get that information from it. So let me go ahead and type these in a list. I'll type in the TI. Actually, might be easier on the Casio. Yeah, let me do the Casio. Because then I can get these sums here. So I'm going to go mode, oops, let me get out of there. Mode 3, number 2. And again, doing this one, you just type in the data. 3175, 3450 Type it in. Type in your y's. Now I have that data in there. I can just get this correlation coefficient by typing number 3 right here, and it tells us it's going to be negative 0.943. So that's what we should come up with using this formula in a minute. I'll just stick that over there for now. So now what I want to do is actually get all of these data values and find their summations. So this is what I'm looking for right here. So n, well, it's 1, 2, 3, 4, 5, 6, 7. N is the number of pairs we have. There's 1, 2, 3, 4, 5, 6, 7 pairs of data. So n is 7. I need the sum of x. I need the sum of y. I need the sum of xy. Let me get those real quick. If we look on the Casio, it does have the sum option. Again, these will be given to you on your test, so you won't actually have to do them by hand. 21065. Sum of y's. 215. Sum of xy. Let's find it. Oh, number 5. 628,500. Let's see what else we need. We need sum of x squared. And we need sum of y squared. So if I'm doing the sum of x squared, that's number 1 right here. 657, 11675, I think. 165, yep. And then sum of y squared, 6769. 69. All right, then we're just going to take all these numbers and stick them in this formula, and we should come up with this. So I'm going to start with the Casio because it is a lot easier to type the information in on the Casio. So n, it was 4, start with fraction, times sum of xy was this number, 628,500, minus sum of x, 210, 65, times, make sure you put the times between each of them, 215. You also group them in parentheses, but that's just more work than it's worth to me to use a times symbol. Don't forget the square root, and is again, oh, where did I say that would have been terrible. And it's 7. I don't know why I put 4 up there. So n is 7 times sum of x squared, that's this number right here, 657,11675. And then we're going to subtract the sum of x, 21065 squared. That's the end of this fraction, or this square root. So I get out of there and hit the times button. Put the other square root button. N is 7. This time we're dealing with the y's. Times 6769. Then minus sum of y, 215 squared. And hopefully I typed in everything right and we get the same thing right here. Oh, look at that, negative 0.9439, et cetera, et cetera, et cetera. So that's our correlation coefficient. That's the formula to calculate it if we're given this information. Again, I will actually give this to you. You won't have to find out with the calculator. I'll either give you this information or I'll give you the data. I won't make you find the information from the data. So now that's what our R is. Let's see what the question asks. Is there a linear correlation between weight and highway fuel consumption? Well, that's a pretty good one. Let's see. Go to my chart, table A6, N was 7. So at alpha is 0.05, it's at 0.754. So yeah, there's a correlation. 0.01, it's 0.875. Yeah, it's a strong correlation. There is a strong correlation here because this, the absolute value, we don't care about the negative. To see if it's a correlation or not, we look at the absolute value. The closer that is to 1, the stronger the correlation. So this is above 0.875. So yes, there is a strong, and then, well, we'll say that in a second, correlation between weight and fuel consumption. Go down there. Where am I? And the second part said, I don't think I spelled that right, who cares? The second part said, what does this tell us? Well, it's a negative correlation. So since the correlation is negative, heavier vehicles consume more fuel. So it's a negative, so as one goes up, the other goes down. As weight goes up, the fuel consumption, the MPGs you get, goes down. So that's saying the heavier car, the worse it is on gas mileage. What do the results suggest about a national program to reduce fuel consumption? So it says make the cars lighter. You can reduce your fuel consumption. That's what this says. Okay. So again, 2 key points. Closer R is to 1, that is the absolute value of R, the stronger the correlation. If it's a negative, it's an inverse relationship. As one goes up, the other goes down. If it's positive, it's a direct relationship. As one goes up, the other goes up. I'm gonna hate myself now. Any questions on those so far? Check. No one on there. Okay. So next question. It just says find the regression equation. That's it. So for the next 2, all we do is get the equation for the regression line. So both Casios and TIs do this pretty much instantly. Start the TI. So I'm going to go to Stat, Edit, clear all this mess out. Go to the top, highlight list 1, list 2, clear and enter, clears that list. And then I'm going to type these in, make sure that we have the right number of numbers. And we should have 5 numbers, well, 5 pairs of numbers. 1, 2, 3, 4, 5. Good. Now all we do is run a linear regression. So again, that's stat, right, number 4. And it should pop up with this once you hit enter. So we don't need the correlation coefficient on this one. We need the regression equation. So that's this part, the A and the B. It's slightly different labeling for the Casio and the TI. For the TI, it's AX plus B. That's slope-intercept form. So y equals 0.643x plus 0.857. That's it. That's the regression equation. Done. Casio users, pretty similar. I'm going to go mode, again, mode 3 and then number 2. But notice, let me take a picture of this, what mode 3.2 says. It's A plus BX. So instead of AX plus B, Casio users have A plus BX. So you just need to take a note of that whenever you're writing down what A and B are and turning that into your regression equation. Oops. AC to get out of there, shift. I did not say, hey Siri, go away. We need the variables, number 4, no. We need the regression, number 5. We need that A, we need that B. So A, 0.857, screenshot it. There we go. So there's A, shift that 5, and there's B. Plug in those numbers and you have your regression equation. So for the Casio users, it's A plus BX, be careful. So it'd be Y equals 0.857 plus 0.643x. Notice these are the exact same equation. Just the order is different. Why they do that, you'd have to ask the makers of Casio and TI. So I prefer this way to write it because that's the slope-intercept form. It's y equals mx plus b. I think the formula on your formula sheet actually has it this way: b naught plus b1x. We'll actually do the next one by hand. So any questions on that one? Moving right along. So I'm going to do this one using the formula.
Why we got to learn by hand?
Because on some of them, I'm not going to give you the data. You're going to have something that looks like this. So you have no data to type in the calculator, so you actually have to just type in the formula.
Okay. But I mean, it shouldn't be that hard if you give us the data and we have the formula.
Yeah, that's all you're doing really is just typing it in. That's the entire chapter, is typing stuff in the calculator. And on test 4, you're gonna have 1 regression, 1 correlation. On the final, you're gonna have 1 or the other out of like 30 questions you're gonna have. So it's not a big chunk, but it's an easy chunk. So get that free point. Here we go. So yep, I'm gonna do this one first. I'm actually just gonna run it on the Casio. Clear out of here. Mode 3, 2. 0, 2, 1. Oops, not 2, 1. 2, 1, 4, 8. 6, 5, 4, 0, 6. There we go. AC to get out of there. And why not run it while we're here? Shift, number 1, go to regression. There's your A and your B. So I'll go ahead and take a picture of it, make sure you don't screw up, because those are big, long formulas, and it's easy to type stuff wrong. So there's A and there's B. So we should find this same information using the formulas. I'll stick it right there. All right, so here's the formulas. So here's the equation for B naught. Here's the equation for B1. That's like your A and your B. And here's the format. Y equals B naught, well, Y hat equals B naught plus B1X. While I'm getting this down, is anyone going to be taking any kind of physics? Well, if you do, you'll need to get used to these subscripts. B sub 0, that's B naught, that's an initial condition. And then subsequent conditions, you just number them 1, 2, 3. This is saying the initial condition plus some variable times another condition. That's why they have this notation. But we don't care about that. We're just plugging in numbers. Need to get these summations here. Let me write down what I need. Let's see, I'm gonna need, I already wrote it down over here. I'm gonna be lazy and copy paste. Okay, so let's find all this info. So we need the same information for the regression equations and the correlation coefficient. Let's go get it. First in, that's complicated. 1, 2, 3, 4, 5. 5. Sum of X. Calculator tell us that. You can probably do that pretty easily in your head. It's 15. Sum of X, that means add these together. Sum of Y, 21. Sum of X times Y. Oops, that's Y. 5, 62. Sum of X squared. That's number 1, 85. And sum of Y squared. No. 113. Okay. Now, since I did it nice and neat on the Casio on the regression correlation coefficient, I'll do this nasty bit on the TI for you TI users. Casio users, just type it in, use your fraction and fancy math type buttons. TI users don't have the math type luxury, so you have to use parentheses. Always, always, always put your numerator and denominator in parentheses. So start the parentheses here. I'll calculate B naught first. Move this over a little bit. Or not. Oh, it's grouped. Yeah. And group. Asker it. So open parentheses, sum of Y, that's 21. Put the multiplication symbol, people. X squared, well, that's 85. Minus sum of X, 15. Times sum of XY, 62. That's it for my numerator. So I'm going to close my parentheses. So TI users, if you want, you can use both the TI and the Casio. It is a lot easier to type this mess in on the Casio. Okay, so that's the numerator. For our denominator, make sure we have our division bar and our denominator in parentheses. N is 5. Sum of x squared is 85. Sum of x squared is 15 squared. That's the end of my denominator, so I'm going to close my denominator's parentheses. And it gives me 4.275, just like I got here. So far, so good. Now it's 2b1. Clear that out of there. So open up a parenthesis for my numerator. 5 times 62 minus, and then sum of x is 15 times sum of y is 21. That's it for my numerator. Divided by, open parenthesis for the denominator. 5 times 85 minus 15 squared. Close parentheses for the denominator. Negative 0.025. Same exact thing we got from the calculator. So that's what these equal. So our regression equation is b naught, well, y equals b naught plus b1x. So our answer is y equals b naught plus, and since it's a negative 0.025, I'm just going to leave it as a minus 0.025x. That's the regression equation. That's it. That's the answer done. Questions on that? Nope, last one. So this one, we're going to make the regression equation and predict the value. So I'm going to go ahead and type all this stuff in. Now, whenever we're predicting values, we have to first determine if there is a correlation or not. If there's no correlation, the best predicted value is the average. So if we get a R value of like 0.3 or something, we just have to take the average of whatever the Y is, an interval after in this case. So I'm going to use the Casio first this time, just because. Mode 3, 2, type it in. And if you notice I screw up typing in numbers, let me know, because that is very easy to do. And it very much messes you up entirely. Okay. I got 8 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. Get out of there. Oops. Stop. So again, we're going to go ahead and find the regression equation, because it does tell us find the regression equation first. So we'll do that regardless of if there's a correlation or not. A and B. So A and B. Again, remember, Casio users, your equation is A plus BX. So the equation is Y equals A. Now, it's best if we don't round. So in a minute, I'm going to actually go back and store these values. So shift, recall. well, why not B? It's B. And then if I do B, that's still that. Okay. And let me redo A, since I need to save it. Shift store A equals. Okay. Now that should be A is A and B is B. Good. So we don't like to round until the very end. That's just in general. Science, statistics, math, don't round to the final answer. Use your calculator store function to prevent that. But for writing it down, we can't write down infinitely many digits. So I'm going to write it down as 3 decimal places. So 54.268 plus 0.246x. That is the regression equation, regardless if there's a correlation or not. Now let's see if there's a correlation. So I'm going to look at my R value. Ooh. R value is not looking too good. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8 values. So let's look and see on the chart. I don't think we're going to have a correlation here. 8. The minimum for a correlation is 0.707. We got 0.269. We can double check our values in our calculator, make sure we didn't mess anything up there. But I think we're good. So you would have told me if I messed up, right? So that means there's no correlation. So the best prediction is Y bar. That would be the mean of all this mess. So to get that, we're going to go to shift stat, variables probably. Yeah, Y bar, number 5, 86. That means our best prediction for 100 feet would be 86 seconds, I guess. I don't see what units we have here. I'm assuming seconds. So previous height of 100 feet or anything would best be estimated as 86 seconds. I don't know, whatever units it is. Okay, let's take it back for half a second and pretend that we did get a significant correlation. Let me show you how you'd use that. We're literally just going to plug in 100 into this number right here. So if there was a correlation, we'd go back to mode 1, and we do A, this number right here, plus B, this number right here, times 100, because that's what we're plugging in, height of 100 feet. And this would be our best prediction, 78.9. That's not the case for this one because there was no correlation. So if you get a correlation, you plug it in. If you don't get a correlation, you find the average of your Y values. Let me do that one time on the TI. And this is the last problem, by the way. So TI users, very, very, very the same. Clear this out. Type the info in. So again, tomorrow we're going to start the test 4 review. We should actually probably finish it same time as today, 1:15. And then Thursday, if you have any extra questions, I'll be answering them. Friday is your test at those specific times. Okay, we got the data in there. So I'm going to run a linear regression. Number 4 right there. And we get same information. So either I screwed up exactly the same way twice or I didn't screw up. So yeah, second's more probable. And we get our AX plus B. Remember, TI users, you're just in a different order. The rest of it's the same. You write down your equation. And since R is not high enough to be a correlation, we use the average of the Y values. To get that, we can do I believe we can do a 2-variable statistics. Calculate that, and it should give us Y bar down here. Yep, right there, 86. We do that again, stat, calc. Instead of 1-variable statistics, we're gonna do 2-variable statistics. Because we have 2 variables. And it'll give you all that nice information there. And Y bar is what we're looking for, 86. All right, guys, anyone have any questions?
Nope.
All right. So test 4 is Friday, final exams the Friday after that. We'll be doing the test 4 review tomorrow. Final exam review will be next week.
How long is the final going to be?
It's exactly like we're going to take it exactly like if we were going to McNeese. It's going to be, 4 to 6 on the 1st. So it's,
Okay.
yeah,
So
it's exactly 2
hours.
hours. Yeah. It's going to be 2 hours, the exact same time for everybody. Like everybody that's in McNeese's stats class is going to be taking it at that time. Just like if we were, going to McNeese and actually doing it.
Alrighty.
So this chapter should be pretty easy, some free points on your tests. Again, your test is going to be consisting of 8 questions, I believe, 2 p-tests, 4 total of Z and T tests, random, of course, 1 correlation, 1 regression. For the correlation regression, you could have data, you could have stats, you could have 1 each. Just depends on what the dice roll for you. And if that's it for questions, I'll see you tomorrow.
Big dog.